Hi everyone, I'm Valery Zizganov, a technical product manager for modular equipment at EKF. And I'm here to talk about our Proxima line of arc fault detection devices, AFDDs. There are types, applications, cover their advantages, as well as build a small test bench to see these devices in action. It is no secret that annual statistics show that a staggering 70% of all residential fires in Russia are due to faulty electrical wiring of electrical equipment. More than 6,000 people have died in these fires, and over 80% of residential fires are caused by arc faults. An arc fault, or an arcing fault, is a dangerous, unintended arcing discharge between two parallel conductors or across an air gap in a single conductor. Damage to the conductor or poor contact will lead to arcing. As a result, the resistance at the damaged location rapidly increases, causing the temperature to rise, leading to the charring insulation and its subsequent destruction. An arc appears, and its temperature can reach from somewhere in the hundreds of degrees to thousands, which will likely cause a fire to start. Other reasons for a fire may include weak contact, mechanical damages to the wire or insulation, for example, when drilling a wall, twisting copper and aluminum wire together, aging of insulation. To prevent the primary causes of fire we've discussed above, we must look at creating a multi-lever fire protection system that includes first stage, a circuit breaker that protects against short circuit and overcurrent protection. Second stage, a residual current circuit breaker that protects against ground leakage current. Third stage, AFDD protecting against short circuit and overload if it's an AFDD combined with a circuit breaker, a parallel phase to neutral or phase to ground arc fault, and a serious arc fault. So what is AFDD? Arc fault detection device is intended for mitigating the risk of fire in the terminal branches of an electric circuit due to an arc fault current that in certain conditions, for example, prolonged arcing, may cause a fire. AFDD is a microcontroller device that enables detection of hazardous sparking or arcing using a special mathematical algorithm that can happen due to faults in 230-volt 50 Hz alternating current circuits and electrical appliances. Analyzing distortions and filtering signals to rule out false positives. Arc welding, switched mode power supply units, LED lighting, brushed motors, etc. Isolation of protected circuits from the rest of the power supply in the event of sparking to prevent fires. AFDD complies with IEC 62606 requirements. EKF product range includes two versions of single-phase AFDDs. AFDDs without an integrated circuit breaker, rated for 10 to 63 amps. AFDDs with an integrated circuit breaker, rated for 16 to 63 amps with a C-curve 6 kiloamps. Design features. This device is 36 mm or 2 modules wide, easy wiring using pin or fork modular bus bars, both from the top and from the bottom. Top power feed. Test button to check whether the device is operating properly. Clear visual indication of the device state. A green LED to confirm that the AFDD is operating as intended. A yellow LED to indicate an arc fault. So the green LED indicates proper operation of the AFDD, and the yellow LED shows that the device has been triggered by an arc fault. An operating handle to switch the circuit under load. Contact state indicator that shows red if the device is on or green if it's off. Wiring can be done using copper and aluminum conductors. Increased tightening torque of 2.5 Nm. Cross-section of connected conductors from 1 to 25 square millimeters. Broad range of operating temperatures from -25 to +50 degrees Celsius. In tests, AFDDs made by EKF have demonstrated correct operation at a distance of 100 meters from the source of sparking or from the panel where it is installed. The sensitivity of the AFDD degrades when the sparking occurs at a distance of 150 meters or more. This is due to the physical length of a circuit, which has its own inductance, resistance, and capacitance that together affect the sensitivity of the AFDD. There are different standard approaches to installing an AFDD, for example in a multi-unit apartment building, each with their pros and cons. First option is to install the AFDD after the main circuit breaker. Pros of this option is the relative affordability. Cons, in the event of an arc fault, you would have to hunt it down across the entire apartment. Second option is to install AFDDs on branch circuits. Pros: it's easier to find the fault and the entire apartment won't lose power. Cons: it's expensive. To show how AFDD works, we'll build a modest test bench. Let's have a look. So here we have a test bench to check the correct operation of our AFDD. In this case, it's an AFDD rated for 32 amps, curve C, with a circuit breaker. We have a digital voltmeter and an ammeter that show us the circuit parameters, and a curve C 32 amp RCBO at the input. As a load, we'll use two electric single-phase heating elements connected in parallel with a total capacity of 500 watts and a rated current of 2.5 amps. And as an arc generator, we'll use two carbon rods. Let's start the test. We energize the circuit by switching the 32 amp input RCBO. The digital voltmeter shows 220 volts and no current draw. Now we switch on the arc fault detection device. Notice that the green LED is glowing. This means that AFDD is OK and it's working. Press the test button to see if it triggers. Rearm the AFDD again. Now, we gradually increase the distance between the carbon rods to generate an arc. AFDD had triggered at 2.5 amps, which is within regulatory requirements. I hope that this video was useful for you. Share it with your colleagues, hit the like button, and subscribe to our channel. Have a good one!